Alright, in this video we're going to take a look at how to find what are known as unit vectors, something that's pretty important in not only the section coming up, but also in math courses and also applied math courses, which is physics and engineering, that require the use of unit vectors. So a unit vector where we use the notation, the vector name with a hat. So this little caret symbol above vector v is a hat. Please keep that in mind as you're working on the problem. Students will ask me, what does this symbol mean? And I'll have to remind them it's a unit vector. So a unit vector, which the notation is a little hat on the vector, is a vector that has a magnitude of 1. So like a unit square has a side length of 1, a unit vector has a magnitude of 1. So here in blue I had an original vector v. I drew a circle here just so it's easy to see that the length or the magnitude of this dark black vector here, this unit vector, is 1. And notice how the unit vector is parallel to the original vector. In fact, it's always going to lie directly on top of it, and since they're pointing the same direction, we say they're parallel. But the unit vector will always lie directly on top of the original vector. So not always going to shrink the vector down, because if our original vector, let's say, had a length of a half, we'd have to double it to get our unit vector. But keep in mind that we're essentially either going to shrink or maybe have to enlarge the length of the hypotenuse of our triangle here. And whatever you do to one side of a triangle, you must also do to the other two. So we get vector v by dividing the magnitude of vector v by itself. So essentially, to get the unit vector, find the magnitude of the vector, and then divide the vector by that magnitude. So again, your magnitude is your length, so whatever the length of vector v is, we would just divide it by itself, and when we divide something by itself, we get 1. Now, bear in mind, if we divide the hypotenuse by itself, we're also going to have to divide not x and y by themselves, but x and y by whatever this hypotenuse was. Divide the hypotenuse by a number, you also got to divide x and y by that number. So since we're dividing the vector, the hypotenuse by the magnitude, whatever we do to the hypotenuse, we must also do to the base and the height, which are your x and your y. So that's how you find the unit vector. You just divide the components by the magnitude of the vector. So example 4a, a little bit of work with unit vector here. Given that vector v is 3, 4, and w is 1, -2, those are the same vectors we saw in the last video that we added and saw the result geometrically. Find each of the following. So we got the unit vector for v, or v hat. So first thing we need to do is we need to find the magnitude of vector v. Magnitude of vector v, here I'm using the single absolute value bars, but 3 squared plus 4 squared, we're going to take the square root of that, and we get the square root of 25, which is 5. So now all we have to do is divide 3 and 4, each of the components, by 5. Simple as that. So 3/5 and 4/5. And if we were to graph vector v, and then graph 3/5, 4/5, this unit vector would lie directly on top of our original vector v. And if you find the magnitude of this, 3/5 squared plus 4/5 squared gives you 25/5, which is 1, and square root of 1 is 1. So this not only would be parallel to vector v, but it would also have a length of 1. Kind of like hitting the reset button. All right, part B. Take the magnitude for vector v and subtract 2 times the magnitude for w. So we found the magnitude of vector v to be 5. Magnitude for w, we'll do 1 squared plus 2 squared, gives us the square root of 5. So we have 5 minus 2 times the square root of 5. And that's it. We can't simplify that at all. It's as simple as it's going to get. It's in an exact form. I guess if anything, if you wanted to estimate it, you could type it into a calculator. But as far as exact answers and simplified answers, 5 minus 2 times the square root of 5. All right, part C, v minus the magnitude of v minus 2w. So here we had separate magnitudes we were subtracting, but here it's the magnitude of the difference. that is not necessarily going to be the same as the answer that we got. In fact, most of the time it won't be. So don't just, oh, I see some magnitudes here and v minus 2w. So magnitudes here, v minus 2w. Oh, my answer is going to be 5 minus 2 square root of 5. Not necessarily, no. So let's see what the answer is. First, let's figure out what v minus 2w is, and then we'll take the magnitude of that. So v minus 2w, 3, 4, minus 2, and then 1, negative 2. So distributing the 2, we get 3, 4, minus 2, and negative 4. 3 minus 2 is 1. 4 minus negative 4 is 8. So we're going to find the magnitude of a vector with a horizontal component of 1 and a vertical component of 8. Well, it's 1 squared plus 8 squared is square root of 65. So here we got square root of 65, and right here we got 5 minus 2 times the square root of 5. So these are not even close to being the same answer. All right, finally, part D, we have the magnitude of the unit vector for W. Well, again, the unit vector has, by definition, a length of 1. So a unit vector for W is going to have a length of 1, so that's the magnitude. So the magnitude of any unit vector is going to be 1. And that about wraps it up for this video. On the next video, we'll take a look at horizontal and vertical components and how they relate to magnitude and angle rotated. So I'll see